No, on the official presentation, it's just Jaime, but for the price of one, we have two people, Jaime and Felipe, on stage today. The floor is yours.
Hi, thank you. So, my name is Jaime. This is my colleague Felipe. We are engineers at OmniVector. And today, we're going to be talking about HPC with containers on Ubuntu. This is the agenda for today. Basically, we want to give some introduction to containers and how we can use them on HPC environments. We want to show a small example on how to use them. And I would like to highlight that this is part of the initiative to expand Ubuntu's adoption on HPC environments. As you might know, traditionally HPC clusters are deployed on enterprise Linux, like CentOS, for example. We have a lack of support from some applications to run on Ubuntu. I believe it's also because of that. And I would like to mention that I'm part of the Ubuntu's HPC team, and we've been doing a lot of effort to stimulate the use of Ubuntu also for HPC. Oh, and just a quick reminder, tomorrow we have a talk, we have a panel, and we are going to discuss things related to Ubuntu and PC and how we can improve it. So please attend to that tomorrow also. Okay, for this presentation, we have some key technologies. First, we have Slurm. I don't know if you have heard about Slurm yet, but it's basically an open source cluster management and job scheduling system for Linux. With Slurm, you can actually, Slurm takes care of the job scheduling and resource allocation in the cluster. There are other similar tools for that, like PBS, LSF, but Slurm is the most used one in supercomputers. Uh, of course, we have containers. This talk is about containers. Containers are lightweight, portable, and self-sufficient units that encapsulates everything you need to run your job. Basically, you have a whole operating system, you have your applications, and all dependencies the application needs. Uh, of course, we have Ubuntu, right? This is the Ubuntu Summit. We're here to talk about it also. And Ubuntu is a key, it has a key role in this presentation because we want to stimulate the use of Ubuntu, right? So we can either use Ubuntu as the host system or the container system for this. And we have another tool. It's called Vantage. Basically, it is a workbench that enables us to create clusters on either on-premise or on cloud. It creates cloud-based clusters. And with Vantage, we can easily submit jobs using the web browser, for example. I would like to mention something. It's not in this presentation, but it's the Slurm charms. I'm one of the maintainers of the Slurm charms. This is also from the HPC team. You can check it out in the charmed HPC organization. We have a lot of Slurm charms, so you can easily deploy your Slurm cluster on your local machine with LXD or in any cloud you have, AWS, vSphere, MES, and so on. For, for this presentation, we are going to be using Vantage just to show a quick example on how to create a cluster locally, a demo cluster locally, and start testing your applications with containers. So you might know the benefits of containers. Containers been around for a long time now. It is widely used, especially in cloud environments, to pack and deploy applications. But HPC can also benefit from them. So we have lots of good things with containers. The first one, I'd say, it's isolation. So containers can provide everything you need to run your application on a single software unit, for example. Especially in HPC clusters, this is a good thing because usually we have lots of users, lots of different applications. It's hard to maintain this. Usually we have modules. So for each of the applications and its dependencies, we need to create specific modules for those. And we can create, I'd say, lean clusters. So we can use containers just to run each application, and everything that application needs is inside the container and that isolated. It won't conflict with the host. It won't conflict with other containers. Also, we have portability. This is really important because we can easily reproduce the simulations, for example. We can run a single image on any system you have, either a cloud or a HPC cluster. So it's easy to replicate your setup in different environments. Scalability. In a cluster, we have, like I said, lots of users. It's a multi-user environment. So we must be able to easily meet those demands because we have lots of users submitting distributed jobs that require a lot of computational power. So containers can easily be used in such environment because they scale. And efficiency. So it's good to have all of this I just mentioned, but we cannot have performance loss. So with containers, we can achieve performance close to basically we have the same performance as bare metal because like I mentioned, they are lightweight. So we heard about the benefits of containers. Now I want to talk a little bit about a few containers technologies. So I have a few here, specific design for HPC environments. You might wonder, where is Docker in all of this? Yeah, unfortunately, Docker is not suitable for HPC environments because Docker has some privilege escalation issues. So here we are on an environment with lots of users, and traditionally Docker has not been a good choice for such environments. But we have a lot of options, right? Starting from Singularity / Aptainer. Basically, initially we had Singularity. It's a project from Scilabs, but eventually this project was split in two. So today we have Singularity CE from Community Edition. That one is hosted by Scilabs. Both of them are open source, right? Just Singularity Community Edition and Aptenia. They are open source, but they are different branches now. So Singularity Community Edition is sponsored by Scilabs, and Aptainer is hosted by Linux Foundation. But they have the same proposal. They are still compatible, so we can either use one or another. They are basically the same, right? And they are meant to easy of use on HPC environments. So they work really well with the workload manager. They work really well with Slurm, with distributed file systems, and all of those things we have on HPC clusters. Next, we have Ceros. It has the same proposal, so it's an OCI compatible container engine for HPC. All of them are OCI compatible. OCI stands for Open Container Initiative. Yeah. So it's basically defines some standards on how to run container images. So we can have a single image. It could be a Docker image, for example, and you can run on different container runtimes with no problem because they define the specs and the standards for it. And all of those can easily run Docker images if you want to. Charlie Cloud is another option you have. I haven't used it yet, but it has the same proposal as the other ones, and it's worth mentioning that all of them intend to run privileged containers. So basically, the user inside the container is the same user from the host, which is not true for Docker. For Docker, for example, I can run root on Docker and be just a regular user in the host, and that's why the escalation, the privilege escalation issues comes. But they has this idea of unprivileged execution. And last but not least, we have Enroot and Pyxis. Those both are from NVIDIA. So Enroot, it's a tool to basically get a Docker image and turns that image into a sandbox to run in the cluster. And Pyxis is a little bit different from the other ones because Pyxis is a Slurm plugin for containers. It runs on top of Enroot, so it has Enroot as an underlying tool. And basically, it will create more Slurm, more options that you can use in your job script. Okay, these are just a few examples. Of course, there are more, including for Docker. There are some projects to run rootless Docker. So I recommend you to take a look at this documentation from Slurm. It has a whole list of containers, container types that Slurm supports, how you can install them, links for the specific documentations, how you can configure them to use with Slurm. Nowadays, we have this option on Slurm dash container where you can configure. You have a specific file oci.conf, and you can configure each one of those containers to call them and run them directly on your job script. But you can also, with specific commands from each one of those technologies, you can run them inside the job. In the example, we're going to have a quick demo. We're going to use the simplest way, which is using the comments from Singularity in the example. But you can also check it out for more options in the Slurm documentation. Okay, so what about workloads? I mean, we have a lot of workloads. So a wide range of workloads from academia to industry run on HPC clusters, right? Applications from different fields. We can say, for example, energy, things like fluid dynamics, finding difference, find elements, uh, industries like oil and gas exploration. A lot of those applications needs computational power to run. Also, aerospace, automotive engineering, uh, medical, pharmaceutical, of course, AI. Everything today is about AI, right? And to train neural network for deep learning, we need computational power. So the list just goes on. And those applications can also benefit from containers, especially when they have complex workflows. So containers can make someone's life a lot easier, right? All right, so now I'm gonna let Felipe talk. He's gonna give us some, he's gonna show us how to use Vantage to create a demo cluster and submit a job, right? Felipe?
Thank you, Jaime, for this overview. I'm taking over to present a quick demo here. Starting with the Vantage platform for HPC, we've chosen it because it's the project our team has been working on, and also we have the chance to provide some practical experience for anyone interested and want to talk more details with us after this talk. It's an HPC platform that can combine both cloud and on-prem clusters in a single user interface. We can use a web interface to interact with it. And yeah, it all starts with the sign page. Also inside, we have this cluster section where we can, of course, add both cloud and on-prem clusters. But the main goal here in the demo is that we can prepare a demo cluster. So this we spin up on our local system, and the platform can connect it with it. We can launch a few jobs and play with the system. When we click there on prepare cluster, we get this script we can copy and paste on our local terminal. It has a helper script that use multipass to start a virtual machine. Then we use Cloud Init to install all the dependencies the cluster needs, like Slurm itself, Slurm DBD, Slurm RESTD, to allow us to use remote job submissions, and so on. All right, with the cluster in place, we can change to the jobs section. I have to say, under the hood here, we run an open source called JobBrigade that I happen to be the core maintainer. It's available on GitHub, and I'm happy to talk about it after this call as well. We can start creating the job script. We provide a name and a description, so we can search, we can share, and we can reuse the resources, and also share with team members. And finally, we have the chance to drag and drop the script file itself there, so it will be available for submission. The file we are using in this demo is this bash script. As you can see, we can set some bash parameters up there to control how Slurm will treat and allocate resources for this job. There on line 11, we are building the singular image file from Docker. We have some logic to cache it locally, so we don't need to build it every time we run the job. We can reuse it if it's available on the file system. And on line 16, we use singular exact, so that command, hello world, will run inside the container effectively. Just for demonstration, we are using the base Ubuntu image, but of course, the great goal here is that each application can build custom layers on top of the base image and take advantage of the containers. That's the main goal. All right, with the JavaScript in place, we can submit it to the cluster. Again, we can provide some metadata for the submission, like a custom name, description. We choose the demo cluster that we just spin up on our machine, the execution directory, and a few other things. So we can remote submit it and execute on our cluster. And yeah, finally the submission is done. We can see here the status is created. It will eventually be processed by the system, be submitted. JobRegate will use Slurm RSD to submit to Slurm. So the status will change to submitted. We'll have a Slurm job ID, so we can keep track of this as well. And it will be queued on Slurm. Will eventually run and complete. We can keep track of the status in the entire process here. And yeah, that's what we can do with Vantage using containers. So to summarize our talk so far, containers enable an efficient, easily and maintainable, scalable workflows on HPC clusters. That's the ultimate goal. Many alternatives are available on HPC ecosystem to integrate with Slurm, as we have seen. And yeah, we demonstrate a user case using Vantage and all the technologies we discussed. Thank you very much for your attention. I think we have some time to take any questions.
Any questions? So I guess maybe not HPC specific real quick, but I just wanted to know, did you use like Canva to make these slides? Because they look really good. So
Oh, it's beautiful AI.
Oh,
It's
really?
a nice tool. Yeah.
Oh, sweet. Cool.
AI is taking over everything, right?
All right. But yeah, so thank you for giving the presentation. I know that we, see each other
Yeah.
pretty much every week, but
Yeah.
one thing I kind of wanted to know is with Vantage specifically and like JavaScript, the HPC work that we've done on Slurm, are you kind of looking into using, say, like Slurm's SC run utility that it has for running OCI images? Is that something you're looking to like enable? So there's kind of more seamless container integration, or you could maybe argue like, okay, you don't have to kind of have analysis paralysis where you're looking at all these separate container runtimes and you can just, pick SC run because it does the job.
Yeah. That's like we would like to be agnostic in terms of container technology specifics. For this, we just like to give an overview and open the discussion. Which should be the best option? You know, I'd say the simple answer is whichever suits you better. But and in our case, for example, for the Slurm charms, we started talking about it, thinking about it. So I'd say this presentation is just the kickoff. So from now on, we can start discussing it. We should for sure test all of those, see the pros and cons of each one of those, and maybe provide at least one of those by default in our Slurm charms or in the demo cluster or in any other way anyone here uses to deploy a Slurm cluster. Yeah. I'm not sure if I answered you.
No, it was great. Thank you.
Thank you.
Any other questions? Was everyone dying for the group picture? And
Yeah.
keeping your cool for the good for the team group picture. I'll ask another question. So in Vantage, when you're like provisioning the clusters, are you using Juju in the backend to set it up, or are you using kind of some other provisioner? Because I guess that was one thing that I was a little curious about because I think it's cool if like you kind of have that front end that kind of provides a on Rails like experience for Juju and more or less like the operator sees it, but the user who's setting up the workflows isn't.
Yeah, I see. For the demo cluster, specifically, we are not using Juju, just multipass. To So basically, we create a VM and install all Slurm services into that VM just for a small test. But for Vantage, we can also deploy it, not deploy it, but we can have already our cluster deployed with Juju, for example. And we have cases where we have deployed a considerably large cluster with Juju and using these Slurm charms. And we have an agent running in there connected to Vantage, for example. So Vantage enables us to either create our own cluster, demo cluster, or use one on-premise cluster. Yeah, but for the demo cluster, it's just multipass.
Yeah, it makes sense.
Yeah.
Brilliant, Jaime, Felipe. It was great. Thanks a lot for the chat. Oh, one more question.
Yeah, thank you so much for the talk. My question would be, how responsive is this Vantage thing? So, for instance, can I drop a bunch of tasks and perform it almost real time, or it's really for some batch work in the background? Thank you.
Yeah, it's very responsive. As Jaime said, we have an agent running on the cluster, so all it takes is the agent to do one cycle and pull the pending jobs, submit, and keep track, keep feeding back with updating stats. Yeah.
Hey, it's just in addition, you can check it later. You can sign up to it, create your demo cluster. Just like I said, you just need a multipass on your system. It will generate the script. You're gonna run the script, and you can test it and let us know if you have any questions. After that, please reach out to us. Yeah.
Brilliant. I think we're on time, and there must be gazillion people like queuing out there for the picture. So brilliant. Thanks a lot. Big round of applause.